So the second part of section 6.2, we're still working on calculating volume, but in this case we're going to be using volume by discs and washers. In the previous section we were calculating volume by using different cross sections. So basically we talk about a disc and a washer. They're going to tell us in the problem that we're going to have to take some region and we're going to rotate it about a line of axis of revolution. So sometimes the axis of revolution may be your x-axis and maybe your y-axis or another line. So some familiar types, so imagine taking your rectangle and rotating the region about the x-axis. You'd end up with this particular cylinder right in here. Or if you take a semicircle, rotate about the x-axis, you'd end up with a sphere. So in this case, the last case, again, notice you have this gap between the region you're rotating and your axis of revolution. When you end up with an axis of revolution, you end up with a hole that exists in the middle. And this is a case where you're going to have to do volume by a washer, which we'll talk about in a minute. So the first part is we're going to do a disc. So you want to remember a disc does not have a hole. There's no hole. There's no gap between the axis of revolution and the shape. So for example, if you have some function y is equal to f of x, and again, we're bounding it between the closed interval from a to b, and again, my axis of revolution is the x-axis, or in this case, it could be another horizontal line, which we'll take a look at in a little bit. So if we're going to try and find the volume by our disc method, imagine taking this region and rotating it about the x-axis. And then what's going to happen is we're going to take a slice. And these slices are now going to be circles. And we know the area of circles are pi r squared. So when we go to calculate the volume by our axis of revolution, r is going to be equal to whatever our f of x is. So it's very similar to what we did in terms of calculating the volume by cross sections, except in this particular case, our cross sections are circles. And we're using the formula pi r squared. So when you take a look at an example, this is a calculator question. So find the volume of the solid formed by revolving the region bounded by the graph of f of x equals the square root of sine x and the x-axis, going from 0 to pi. So again, I'm bounding it from 0 to pi. So even without a calculator, you know sine of 0 is 0, square root of 0 is 0. Sine of pi is 0, square root of 0 is 0. So I know this graph is going to have to come up like this and then come back down. So again, I always like to show my axis of revolution by seeing how it's going to rotate around. So I'm taking this region and I'm rotating it around the x-axis. So now again, the r value is going to be your f of x. And in this particular case, f of x is the square root of sine x. So to calculate this volume, I know it's going to be using the area formula pi r squared. So then to calculate my volume is going to be equal to, again, I'm going to pull out my constant of pi. Again, I'm integrating this from 0 to pi of r squared. So that's going to be the square root of sine x squared dx. Again, if you're rotating it about the x-axis, it is a dx problem. It's just like you were looking at the other volume. So if the axis of revolution is the x-axis, it's treated like a dx problem. So then to calculate the volume is going to be pi, going from 0 to pi. And again, when I square the square root, that's just going to give me sine of x dx. Again, the integral of sine x is going to be a negative cosine x. And I'm going to have to evaluate this from 0 to pi. Make sure you leave that constant pulled out, that pi. Plug in your upper bound. Cosine of pi is -1, and negative 1 becomes a 1. Minus. Plug in your 0. Cosine of 0 is 1, so that's going to become a -1. So my final answer will become a 2 pi. Now you may also have volume by a washer. A washer is when you're going to have a gap or a hole between the region and your axis of revolution. So some will have a solid interior, some will have a hole or a channel. So if this happens, what we have to do is, again, we're looking for a closed interval, and again, you're looking, again, perpendicular to the x-axis. So what happens with this particular region, when I take this region R and I rotate it around the x-axis, notice what happens. I end up with this gap or this break between my axis of revolution and the region. So if I rotate this all the way around the x-axis, I end up with a hole. So what you have to do is you have to consider the outer radius and the inner radius. So here's my outer radius, here's my inner radius. So when you're doing a washer problem, you have to consider your outer radius minus your inner radius. So again, you're still going to be considering your top minus bottom, like you were doing for your cross sections. But again, your top function will be your outer radius minus your inner function, which is your inner radius, which is going to be your bottom function. So when you're solving this problem by slicing, your cross section of the solid is taken perpendicular. You're going to get a washer shape. In other words, when I take my cross section, you end up with a hole or a channel in the middle of the middle of the circle. So this is where you basically have to take the area of the outer region and you're subtracting out the area of the inner region. So it's going to be a pi r squared minus pi r squared, or you can factor out the pi. So again, it's going to be pi times your antiderivative from a to b of f of x squared minus g of x squared. Or this is going to be your outer radius minus your inner radius. So when you're graphing your regions, you've got to make sure if you're dealing with a washer, which is the hole in the middle, or a disk, which has no hole. So find the volume of the solid being formed by the region bounded by the graphs of y equals square root of x and x squared. And again, the axis of revolution is we're rotating it about the x-axis. So again, we're still dealing with a dx problem. So first of all, you always want to graph, just like we've been doing in all the other problems you want to graph. So when I graph this, I'm going to graph y is equal to the square root of x. And then y is equal to x squared. So again, I'm calculating the volume in this region. Again, my axis of revolution is about the x-axis. So you can see how you have this region, this gap between your graphs and your axis of revolution. So then the inner radius is going to be this part right in here. That's the gap. Your outer radius is from the top function down to your axis of revolution. So then my outer radius is going to be the function that's on the top, which is your square root of x. Your inner radius, which is the function on the bottom, is x squared. So then to find your axis of revolution, remember it's going to be pi r squared minus pi r squared. So you do have to find this point of intersection, just like what we've been doing, in order to calculate the bounds. So again, your intersection. You come by taking your two functions and setting them equal to one another. So square root of x is equal to x squared. Square both sides, that's going to give you x is equal to x to the fourth. So then 0 is equal to x to the fourth minus x. So 0 is equal to x times x to the third minus 1. So x equals 0 and 1. So your bounds are going to be from 0 to 1 comma something. So to calculate the volume is going to be equal, again, I can pull out this pi because I'm only squaring r. My bounds are going to go from 0 to 1. Now remember, I have to take the square root of x and square it. That's my outer radius minus the inner radius, which is going to be my x squared dx. So now I have pi going from 0 to 1. When I square root, that's going to give me an x minus x to the 4th dx. So now I can integrate, keeping my pi on the outside. I end up with x squared over 2 minus x to the 5th over 5. And again, I'm going to integrate from 1 to 0. So I have pi times, plugging in your upper bound of 1/2, minus 1/5. Remember, if it's a free response question, you can leave it alone. You do not need to get a common denominator and subtract. So again, with the dx's, you're still doing top minus bottom if you have the washer. Now you may also have an axis of revolution for discs and washers that are perpendicular to the y-axis. So again, notice the region now is going to be revolved around the y-axis, no longer the x-axis. So just like you've been doing, what you have to do is you have to get the equations in the form of x equals. And again, your bounds are going to be y values. Again, when you still do your slicing, there's still going to be circles, but now notice the radius and the circles are perpendicular to the y-axis if it's a disc. Notice the difference if it's a washer. You've got this gap between your plane and your axis of revolution. And what happens here, that's creating a hole in the middle of your circle. So you still have to consider your outer radius minus the inner radius, because this is all going to be hollow. So you have to subtract, you're finding the area of the whole entire region, and what you have to do is then find the area of the inner region, and you're going to subtract it. So it's still going to be the outer radius minus the inner radius. And again, it's going to be your right minus left. So find the volume of the solid. That's generated by rotating the region. Again, it's about the y-axis. So this is going to be a dy. So let me go ahead and sketch my curve. So the region's bounded by y equals 8. There's 8. X equals 0 is my y-axis. And then x to the 3rd, remember, is my graph that looks something like this. Again, my axis of revolution is about the y-axis. So again, I want to calculate the volume of this region. And again, I'm rotating it about the y-axis. So notice there is no gap between my axis of revolution, which is the y-axis, and the region. So this is a disk. I don't have to worry about finding that inner radius and the outer radius. The big thing is, remember, because it's a dy, I have to solve for x. So my radius is going to be equal to, when I solve this for x, y is equal to x to the 3rd, then I know that the cube root of y is equal to x. That is my r. So to calculate the volume, I know the area of a circle is pi r squared. So again, I'm going to integrate, pulling out that pi. And I have to take the cube root of y, and I'm going to square it, dy. So then again, because this is a dy, remember your bounds are going to be in terms of the y values. So notice the lower bound is going to be a 0, the upper bound is going to be an 8. So again, I know cube root of y is actually y to the 1/3, and when I square that, that's going to give me pi going from 0 to 8 of y to the 2/3 power, dy. So then when I integrate, I'm going to have pi times. When I integrate y to the 2/3, that's going to give me y to the 5/3 divided by 5/3 or multiplied by 3/5. And again, I'm going to evaluate this from 8 to 0. So I can leave my pi on the outside. times 3/5, plug in 8 for y, so 8 raised to the 5/3. And again, if it's a free response question, leave it alone. You do not have to evaluate this. Or if it's a calculator question, you can use your calculator. So this is what happens when your axis of revolution is the y-axis. So here's another example of a volume generated by revolving the region bounded by x equals 2y minus y squared and y equals x. And again, you're revolving it about the y-axis. So when I sketch my graph, I know y equals x is a line passing through the origin with a slope of 1. Now, 2y minus y squared. This is a parabola, and because y squared is negative, it's going to be opening to the left. So 2y minus y squared, again, if I factor out the y, I can find my y-intercepts. So my y-intercepts is 0 and 2. So my graph is going to look something like this. So in the region that again, it's the region. Make sure you highlight the correct region. It's bounded by these two curves, not the y-axis and the curve. So this is the region that I want to calculate the volume for. So you can see, since my axis of revolution is the y-axis, you can see how I have this gap between the region that I'm rotating and the axis of revolution. So I have to find my outer radius and subtract from that my inner radius. So my outer radius is the function that's on the right. So remember that whole right minus left when we were doing cross sections. And the function on the right is the parabola, which is your 2y minus y squared. The inner radius is the function on the left, which is just y equals x or x equals y. Now again, to find your bounds, we have to find the points of intersection. So remember, we're going to take the 2y minus y squared and set it equal to y. So 0 is going to be equal to y squared and minus y minus 2y. Factor out a y, so y is going to be equal to 0 and 1. So there are your bounds. So again, remember it's going to be a pi r squared minus pi r squared for the washer. Because again, I've got that gap between my region that I'm rotating around about the y-axis. So then to find the volume, it's going to be pi. Again, I'm going to be integrating from 0 to 1. So this is my point of intersection 0. This is something, comma, 1. Because I'm rotating about the y-axis, remember my bounds are in terms of y. So then it's going to be pi times. Now remember, this is all my radius, so I have to take 2y minus y squared, and I'm going to square it, minus my inner radius squared, dy. So my volume is going to be equal to pi, going from 0 to 1. Remember, be careful, I have to FOIL this, 2y minus y squared times 2y minus y squared. So 2y times 2y is a 4y squared. Minus 4y cubed, or excuse me, minus 2y cubed minus 2y cubed is going to be a minus 4y cubed plus y to the 4th. Minus y squared. And again, I have to integrate this. There's no like terms I can combine. Actually, I can combine a 4y squared and a negative y squared, which will give me a 3y squared. So I'll have 3y squared, and when I integrate 3y squared, that's going to give me a 3y to the 3rd over 3, which will give me a y to the 3rd. This is going to give me a minus 4y to the 4th over 4, which will reduce to just y to the 4th, plus y to the 5th over 5. And remember, this is all going to be multiplied by pi. Again, I'm going to evaluate this from 0 to 1. So I have pi times 1 minus, again, I plug in a 1 here, it's going to give me a 1, plus 1/5, which would just give me pi over 5. Now, sometimes besides having the axis of revolution be the x or y axis, they may give some other line of revolution. So, for example, you still want to do top minus bottom, right minus left. Remember, if it's a horizontal line, your x-axis is horizontal, so you treat it like a dx. If the axis of revolution is a vertical line, your y-axis is a vertical, you treat it like a dy problem. So here's an example where you have other axis of revolution. So like I said, what happens when the axis of revolution is a line other than one of the axes? Find the volume of the solid obtained by rotating the region enclosed by the graphs of y equals x squared, and the x-axis, and you're rotating it about the line y equals 2. So again, the line y equals 2, and I always like to show my axis of revolution with a highlighter. Notice it's going in the same direction as the x-axis, so you're going to treat this just like you would a dx problem. Again, I'm rotating it about this line y equals 2. So my graph y equals x is a line with a slope of 1. And again, I've got the equation y is equal to x squared. Again, I'm going to calculate the volume of this particular region. So now, notice this is going to be a washer. I have this gap between the axis of revolution and the region that I'm rotating it around. So I still have to, since this is a washer, I still have to identify my outer radius. I still have to identify my inner radius. So then my outer radius. Now remember, now this is where you have to consider the axis of revolution. So my outer radius is going to be from 2 minus, so top minus bottom. Because the axis of revolution, you have to do top minus bottom to consider the outer radius and inner radius. So it's going to be 2 minus x squared. The inner radius is going to be 2 minus x. So when your axis of revolution is no longer the x or y axis, it's going to be top minus bottom. In this case, the axis of revolution is on the top, so it's going to be 2 minus the function furthest on the outside. So to calculate the volume, I then have to figure out still my bounds. So I know that this is going to be 0, 0. So my bounds are going to be found by taking these two equations and setting them equal to one another. X equals x squared. So x squared minus x equals 0. X times x minus 1. So x equals 0 and 1. So I know to calculate this volume, it's going to be pi, pull out the pi, going from 0 to 1. The outer radius squared, which is 2 minus x squared squared, minus your inner radius, 2 minus x squared dx. Again, watch your foiling. So when I foiled 2 minus x squared, that's going to give me a 4 minus 4x squared plus x to the 4th. Minus, make sure you keep this set of parentheses opened up. That's going to be 4 minus 4x plus x squared dx. Again, it's pi going from 0 to 1. Now notice what happens here. You end up with 4 minus 4. That's going to cancel. Negative 4x squared minus x squared is going to give me a negative 5x squared. I have a positive x to the 4th. And then I have minus a negative 4x, which is a plus 4x. Now I can integrate. So that's going to give me a negative 5x to the 3rd over 3 plus x to the 5th over 5 plus 4x squared over 2 is going to give me a 2x squared. And again, I'll evaluate this from 0 to 1. So that's going to give me pi times negative 5/3 plus 1/5 plus 2. And again, free response question, you can leave it alone. So now, here's another example. Find the volume of the solid generated by revolving the region around the graphs x equals y squared, x equals 4. And again, I'm going to do an axis of revolution about the line x equals 5. So let me first do my sketch. Well, x equals 4 is a vertical line. The graph of x equals y squared is a parabola opening to the right. My axis of revolution is x equals 5. Now notice, since this is a vertical line, it's going in the same direction as your y-axis. I know I'm going to treat this just like a dy problem. So then notice, I do have, since my axis of revolution is x equals 5, I do have this gap, this break, between the region that I'm rotating, because again, I'm trying to find the volume of this particular region right in here. So I have this gap between the axis of revolution and the plane that I'm rotating. So again, because this is a dy problem, I have to consider right minus left for both my outer radius and my inner radius. So my outer radius, going from my axis of revolution to the function that's furthest on the outside, that's my outer radius. So that's going to be 5, because again, what's on the right is my axis of revolution, minus x squared. My inner radius is again 5 minus 4, because that's the equation of the vertical line, which is just going to give me 1. Again, it should be 5 minus y squared. So then, to calculate the volume, again, the bounds have to be in terms of y, so I need to find these points of intersection. It's simply going to be y squared is equal to 4. Take these two equations, set them equal to one another, so y is equal to plus or minus 2. So there's my something comma 2, something comma negative 2. So the volume is going to be equal to, again, pi, going from negative 2 to 2, of, again, my outer radius, which is 5 minus y squared squared minus 1 squared dy. So again, when I square this, it's going to give me 25 minus 10y squared plus y to the 4th minus 1 dy. And again, 25 minus 1 will give me a 24. So when I integrate, keep your pi on the outside, that's going to be, again, 25 minus 1 is 24, so that's going to give me a 24y. Minus 10y to the 3rd over 3 plus y to the 5th over 5. And again, I'm going to evaluate this from negative 2 to 2. So that's going to give me pi. Now remember, you do not have to work this out. Plug in my upper bound. 24 times 2 minus 10 times 2 to the 3rd over 3 plus 2 to the 5th over 5 minus. I'm just going to recopy this so it's got a little squished here. So I have pi. When I plug in that upper bound, remember, pi is on the outside. I have 24 times 2 minus 10 times 2 to the 3rd over 3 plus 2 to the 5th over 5. I should close that bracket yet. Minus. Now plug in your lower bound. 24 times negative 2 minus 10 times negative 2 to the 3rd over 3 plus negative 2 to the 5th over 5. And remember, all of that is being multiplied by pi. And again, remember, if it is a free response question, as ugly as this is, you do not have to work it out. Now, what happens when you have a axis of revolution that's now going to be x equals negative 2? Still the same region. I'm just going to do the separate piece of paper so I don't get squished. But now my axis of revolution is x equals -2. It's still a vertical line, so I still have to treat this like a dy. So I still have the region that's bound between x equals 4. So I've got my parabola. These points of intersection are down here at something -2, something +2. Again, I'm taking this region and I'm going to rotate it now about the line x equals -2. So again, you do have this big gap, this big break between the region you're rotating and your axis of revolution. So this is another washer. So you have to consider your outer radius. So again, since this is a dy, you have to consider right minus left. So going all the way to the right, the function that's furthest on the right is 4. There's your outer radius. Oops, stuck in my hand. So your outer radius, again, knowing you're going from function on the right. Your inner radius is the parabola to the axis of revolution. So the outer radius is going to be 4 minus -2, which is 6. The inner radius is going to be your y squared minus -2, or y squared plus 2. So then when I integrate, it's going to be, my volume is going to be equal to pi times the antiderivative from -2 to 2. The outer radius, which is 6 squared, minus y squared plus 2 squared, dy. So it's going to be pi times the antiderivative from -2 to 2 of 36 minus, now make sure you watch your signs here, this is going to be y to the 4th plus 4y squared plus 4 dy. So when I integrate, I'm going to have pi. I know 36 minus 4 is 32, so that's going to give me a 32y. Distribute the negative sign, that's going to be a minus y to the 5th over 5. That's going to be minus 4y cubed over 3. And again, I have to evaluate this from -2 to 2. So I have pi, again I'm going to open up a big set of parentheses and a bracket, plug in my upper bound, so I have 32 times 2 minus 2 to the 5th over 5 minus 4 times 2 cubed over 3. Minus, plug in a -2 as my lower bound, 32 times -2 minus -2 to the 5th over 5 minus 4 times -2 to the 3rd over 3. And again, if it's a free response question, you can leave it alone.